This video being supervised by the Venerable Vasya. Oh, no, he changed his mind. He's not going to supervise. He's had enough. He doesn't want any part of this lesson. So this is to take you through activity 1.3.1, which is called the whole story. And we're going to do the distance learning version of this just because it's a little bit simpler and easier to get our heads around. So this video is going to summarize what we're doing for activity 1.3.1 and give you an idea of the layout if you're absent on the day that we started or you're absent on the day that we do any part of this activity. You can watch this, fast forward to the parts that you need and so forth. I don't think this video is going to be particularly long. So the deliverables, putting this at the beginning, what do you need to submit at the end of this activity for a grade? So each student, note, each student will submit for grading the 2 completed tables in his or her engineering notebook. So you cannot just say, well, my partner wrote down the data in the table, so I'll turn in their notebook. Nope, you've got to have it. If you're absent on the day that we collect any of this, I will try to remember, but if I don't remember, you want to contact your partner. You need to get the data so that you have it in your notebook. So the values of the range for each class data set, and then a summary statement comparing the precision of the ruler and the calipers. Okay, so there's like 4 things that are going to be in your notebook. 2 tables, some precision measurements, I guess that's like 2 things, and a summary statement comparing the precision of the 2. And then each student will also complete a practicum quiz on the use of the calipers. So a practicum, that's like kind of a college-y sounding word there. A practicum is like a practical part of a course. So if you're like a nurse, you might go into a hospital to complete your practicum. Students that are in lab classes will have like lab practicums where they have to demonstrate that they can do the things with the materials like in the lab. So it's kind of like that. You're going to be handed a pair of dial calipers, you're going to be handed a gauge block, and then you're going to take some measurements and then go into Go Formative and record those measurements to demonstrate that you know how to use that piece of lab equipment. So those are the things that you will submit for this activity. To measure is to estimate. This is the introduction to the activity as provided by PLTW. And I'll just read through this. It's not bad. Modern civilization cannot exist without measurement systems. Measurements are everywhere and used every day. Every time you buy gas, check the outside temperature, or step on a weight scale, you rely on a measurement to communicate information. But a measurement is only an estimate of a quantity. So you notice the title of the slide is to measure is to estimate. What does it mean? We can never know the exact measurement of something because the act of measuring always involves uncertainty. There is always some error in measuring. And you guys know that I live half in math world, and math world is really accurate, and you calculate the slope and you can know exactly what it is. And the real world just doesn't work that way. Doesn't mean we can't use the math and the math skills and the math tools. It just means that we have to account for uncertainty. So here are some places where you might see some uncertainty. You may make an error reading the measurement, or the measuring tool could be calibrated improperly. So when you go into PLTW, if you hover over that, it'll give you the definition. Calibrated means that it's set wrong. And so like a scale that's not calibrated might, it's not calibrated correctly, might show that there's weight on it when there's nothing on it. And so you would have to adjust that. So usually you adjust it so that when nothing is being measured, the reading on the device is 0. Perhaps the object has imperfections so that you read a different value at a slightly different location on the object. I know the older version of this activity had you measuring the width, not the width, but the depth, right? The skinny part of a credit card. And you think oh, a credit card, that's the same thickness all the way through. And yet it's often not, not when you get accurate enough, and precise, enough in that I'm being kind of careless with my use of those words. I'm sorry. Perhaps so you might measure the thickness of a credit card in one spot and you get one measurement, and then you measure it somewhere else and you get a different measurement. And they're going to be different by a lot, but they are different. And no matter how carefully you measure or read a device, you cannot measure more precisely than the measuring device allows. So the true value of the quantity may be slightly greater or slightly less than what you read on the device. So if you have like a bathroom scale or something that measures to the nearest tenth of a pound, I think mine does, like it does the nearest tenth of a pound. I don't know anything about the hundredths or thousandths value of my weight when I step on the scale. Now, there are hundredths and thousands values, but my scale doesn't show me that. And so I can never know my weight to that level of precision because my device isn't that precise. So sometimes a rough estimate of a measurement will meet our needs. For instance, I gotta make my face disappear. Measuring your mass to the nearest kilogram or weight to the nearest pound on a common digital scale is probably sufficient when recording your weight during an annual physical exam. Like your doctor doesn't need to know your weight to the nearest 10,000ths of a pound. Like you don't need to know it that much. But if you want to measure the mass of a single cell to analyze changes in a cell over time, you need a more precise estimate, perhaps to the nearest hundredths of a nanogram. So how precise you need a measurement to be depends on what you're doing. And I know like some things just like they just don't need to be that precise. Other things like the shape of a wing on an airplane, like that has to be really, really, really precise. Like it just a small error, it can be catastrophic when you're dealing with like flight and planes and aeronautical stuff. So before we go any further, copy both of these tables into your engineering notebook. So you need one table that's got like wire diameter in inches, and it's going to have an estimate, a ruler measurement, and a caliper measurement. That is your group, like, or your partner, you and your partner, what you get. So you want that in your notebook. Then you want the class data table, and I set that up for 15 groups. That should accommodate like both of my engineering classes, at least the year that I'm recording this, for everybody. If we, don't have that many groups because people are absent or whatever, then you'll have a couple extra rows in it. But then you want a column for the ruler measurement and a column for the caliper measurement. So if you're watching this from home and you don't have that in your notebook, pause the video here and copy that into your notebook. Make sure that you leave yourself enough space to be able to write in your table because you're going to have some numbers that you need to write there. Okay, so in class, what we'll do for this is I'm going to give each group a wire sample, and you are going to estimate the diameter of the wire to the nearest 1/64th of an inch. So you might not know how big that is. So you are allowed to look at a ruler to determine how big a 1/64th of an inch is, but you may not actually lay the ruler up against the wire, like your estimate only. So just look at it and say, I think this is 1/64th of an inch or 2/64ths of an inch or 3/60, like how many of those little tiny marks do you think the diameter of your ruler, your wire is? And then write your estimate in your table in your notebook. Both teammates should have their own tables. Again, you may not share tables. So both teammates need to have it. Now, if you're absent the day that we do this, you can use your teammate's estimate. Like that's fine. Like you don't both have to do an estimate, but you both have to have your own table. So you want to reach out to your teammate and just say, hey, like what did we get for those numbers for today? Okay, then you are actually going to measure the diameter using the ruler. So use the ruler to actually measure the diameter of the wire. Estimate to the nearest half of a 64th. Okay, so your estimate without using the ruler was just like a straight up estimate. Like you're not looking at, you're not measuring at all. Now you're going to lay the ruler up against the wire. And I want you to measure it. You're going to be able to measure it accurately to the nearest 64th, we hope. But I want you to estimate to the nearest half. So is it like 1/64th, 2/64ths, or maybe you think it's like 1.5 64ths. Now, normally in math, we don't like to combine fractions and decimals in the same number, okay? But for this purpose, I think it's fine. So if you think it's 2.5 64ths, somewhere between 2 and 3, and you're like, you don't want to commit to one or the other. Now, if you think it's exactly 2/64ths of an inch, like that's fine. You could just say, I think it's 2/64ths of an inch. But if you think it's like a little bit more, you can say 2.5. In your notebook, write a brief statement about how close your estimate was to the value you got with the ruler. And again, like, don't go back and like change your estimate to say, oh, I estimated exactly. Like, that's not the point. The point isn't like, can you do perfect work all the time and estimate things perfectly? It's just to increase your awareness of your estimates and how close you get. Now, when instructed, you're going to enter your measurement in the class table, and that's what you have like copied into your notebook already. We'll put that up on, we might put that up on the board. I might just put it on the screen or something. Not sure at this point, but we'll have a class table and then copy the class table into your notebook as it fills in. So as it fills in, so you're going to have a copy of the class table. We'll have the class table like either on the whiteboard. It depends on what my Algebra 2 kids are doing, how much board space I have for it. But and then you're going to copy that into your notebook. Then we're going to talk precision. So recall that precision is a measure of how close data values are to each other, or that is how repeatable a measurement is. So when we did that with the beanbag launcher, you had to like launch the beanbag and then you do the circle around it. And like the smaller the circle, the more precise your beanbag launcher was. So what we're going to do is look at the class data and find a measurement of precision by finding the range of the numbers. Now, range in statistics, that word when you're in the branch of math known as statistics, means the difference between the highest and lowest number, which is different from the definition used in algebra. So in algebra, range is like all of the possible outputs of a function. Okay, so it's like just two different branches of math, and that word is used in both branches. So what you're looking for is the difference between the highest and the lowest number. So find that and then write your value for the range in your engineering notebook and be sure to label and circle it. Okay, so that when I'm looking at your notebook, I'm going to like be able to see very clearly, oh, like here's their measurement for precision for the ruler. Okay, so have that easy to see. Now, the lesson is going to break here. And at this point, we're going to break for a lesson on how to use the dial calipers. So dial calipers are a precision measuring tool. They're very, very accurate. Some of ours are a little bit wonky, and you'll figure out what that deal is. But that's a whole separate skill. So that's like separate from this whole lesson. Yeah, we got to go how to like zero the calipers, and then there's 4 different ways that you can make measurements with the calipers. Okay, so we're going to do that. This lesson will come with its own activity and a practicum quiz in which you use the calipers to measure a gauge block. A gauge block is a block of standardized size whose dimensions are known, and so it's not like measuring like a credit card that doesn't really have a standardized size, that it could be different. Like the gauge block, like you're going for a specific answer on that. And I'll probably have you measure a couple of things, to demonstrate that you can use the calipers. Okay. There is a PowerPoint lesson in the Wakelet that we'll use in class that'll kind of walk you through it, and we'll do demonstrations like in class with it. So there's like a little lesson embedded in this one for how to use the calipers. Once we have cleared that lesson, then we need to measure the diameter of the wire. So at this point, now that you have learned how to use the calipers and have demonstrated that, and if you're absent when we do the caliper lesson, that you need to make up. So you need to come in before school or after school in order to be able to watch that. I might have a streams video from last year where I did it. I'll see if I can look that streams video up so you could watch that at home to get the tutorial. I'm pretty sure I did. On that. So once you've demonstrated that, you're going to use the calipers to measure the diameter of the wire and record that answer in your table. So at this point, like your table should be filled out, and then when instructed, enter your measurement in the class table and then copy the class table into the notebook. So at this point, like you should have like both of the tables filled out, and then repeat the precision calculation, this time with the caliper measurements by finding the range of the numbers. Write this number in your notebook and be sure that it is clearly labeled. Now, the calipers, some people are going to be really good at using them and some people not so much. And I just know that because I've taught this. This is the 3rd year that I've taught this class. So it is possible that we're going to have some like data in that table that you're like, not right. And we'll cross that bridge when we get to it. Like, how do you identify whether or not this is a human error and not like a device error or a normal part of the variation in measurements? And then a summary statement. So in your engineering notebook, write a quick summary comparing the precision of the ruler to the precision of the calipers. Remember, when we talk about comparing, we usually mean greater than, less than, more, less, it's more accurate, precise. Well, we didn't really talk about accurate unless we know what the actual diameter of the wire is, but you can make a statement about the precision. What you will turn in, at least the year that I'm recording this, which is 2021-2022 school year, is you're going to put a little sticky note in your engineering notebook on the page where this work is, so that I can pull your engineering notebook, flip to that page, look to see that you have the tables, the precision measurements, and your summary, and that's how you're going to submit the work for this lesson. So this, hopefully this helps you get your feet on the ground in terms of what this next lesson is, what we're going to do, and what you're missing in class if you're absent. Always be proactive. Watch this video and then contact me or your teammates to find out what data you need.